Welcome to the video tutorial on pressure. So pressure is an important topic when we're looking at gases. Solids and liquids, at ambient conditions, there's not a big deal with pressure, but gases have a huge effect. So the first thing we want to do is, what's the definition of pressure? Pressure is a force over area. So an example of this would be if I'm pressing my hands together, we would have equal force between them, and so there's the pressure I feel. But now with one hand, if I change my force to the tip of my finger, now this hand feels the pressure because the force is being applied over a small area, versus if I've applied the pressure, the force over a large area. So here we would have equal pressure because we have equal force over equal area. This would be uneven pressure because the force is being applied over a smaller area. So there's the definition of pressure. And so, for example, PSI, if you've ever filled your tires with air, PSI stands for pounds per square inch. So the pounds is the force, and then the inches squared is the area. So there are a wide range of ways to measure pressure. One of the first ways we measured pressure was with a barometer. So the way a barometer works is it's filled with mercury. And in the olden days, human beings, we loved mercury. We've used it for all types of things. But here we're going to use it to measure pressure. And so what we have here is a sealed and evacuated tube. All right, so all of the gas molecules have been removed from this tube, and it's sealed. And so then if we stick it into a tub of mercury, so the mercury is sitting here, and so what happens? Well, we're all experiencing 1 atmosphere of pressure. So that 1 atmosphere of pressure presses down on the mercury and pushes it up the evacuated tube to fill that empty space. And so then what happens is, if we measure this column of mercury, we will see that it measures 760 millimeters. So the pressure units, they seem very strange. Here's 1 atmosphere. That could make sense. So now we can see how 1 atmosphere equals 760 millimeters of mercury. That's the height equivalent of the mercury column from pressing down with 1 atmosphere of pressure. When the barometers were first used, we didn't have the metric system yet. So at that time, several hundred years ago, they used the unit torr. So we can see that millimeters of mercury and torr are the same size unit. So they can be interchanged. Then, if we did a unit conversion, guess how many inches are in 760 millimeters? You got it, 29.92 inches. So this was just a millimeter to inch unit conversion, right? So we could say that, or 29.92 inches of mercury. And here's the conversion to PSI, which if you think about tires, seems like tires usually want 30 to 40 PSI of pressure, which would be about twice the atmospheric pressure, so that seems reasonable. And then PA, this stands for pascals, and this is from the SI unit system, which we are not working with, but I wanted to have it there for the sake of completion. So pressure is primarily going to be used in gas law calculations, and so it's important that you recognize all of the different units that can be used to communicate pressure. Just to kind of fill in some context, blood pressure is the pressure exerted by blood on the walls of the blood vessels. So the systolic pressure, that's the maximum pressure. And notice that when we get our blood pressure readings, they're given to us in millimeters of mercury. So a normal systolic is in the 90 to 130 degree range. The diastolic is the minimum blood pressure, and so that's also given in millimeters of mercury with a normal range 50 to 90. Some other places that we're going to encounter pressure units will be when we talk about vapor pressure and the boiling points of substances. So the more volatile a compound, right, will have higher vapor pressure. So volatile compounds have higher vapor pressure. And that will become important if you're curious about the relationship between vapor pressure and intermolecular forces and boiling points. We do have a video tutorial to help you with that. And the main point of this page here, though, is to see that here's our temperature, that as we increase the temperature, we increase the vapor pressure. And then the last place that pressure shows up in a big way in our course material is that the atmospheric pressure does change with altitude. And so what we consider our normal pressure at sea level drops significantly as we rise above sea level and increases as we go below sea level. So this concludes a brief introduction to pressure and its units, and gives you a bit of a context for where you will use this information for future assignments. So if you're working on your gas law homework right now, it'd be great to work a few practice problems to reinforce your understanding of pressure units and how it plays into gas laws.